We're going to be discussing electronegativity, and then in the next video we're going to be talking about how electronegativity is used to determine which bonds are present between two atoms. When we are determining electronegativity, we have to understand that the electronegativity is the tendency of an atom to hang on to its electrons, specifically its valence electrons. Remember that the valence electrons are the electrons in the outermost shell. And electronegativity is going to increase as we go this way towards fluorine on the periodic table, and then also, this is a little counterintuitive, as we move upwards. So let's talk about why this happens. We have to remember that an atom has a nucleus, and in the nucleus we have protons. Protons are positively charged. And so as we move towards fluorine on our periodic table, we are increasing the number of protons. So hydrogen is going to have 1 proton, and carbon is going to have 6 protons, and nitrogen is going to have 7, and etc., etc., etc. So these are going to keep increasing and increasing as you go this way. So as you have a larger and larger nucleus, or a larger and larger positive force, it's going to have a larger and larger attractive force to those negatively charged electrons. So therefore, the tendency of the atom to hang on to those electrons increases because it has a larger positive nucleus. Now, it also, we talked about how it goes up, how it increases as it goes up. Let's talk quickly about why it decreases as it goes down the periodic table. So hydrogen, we have a picture of hydrogen here. Hydrogen has just 1 little electron really close to the nucleus. So because it's close to the nucleus, it's going to be attracted very easily to that positive charge. However, as you go down the periodic table, lithium is going to have 2 orbitals, and sodium is going to have 3, potassium is going to have 4, rubidium is going to have 5 orbitals to fit all of those electrons, and finally cesium. Cesium is going to have 6 orbitals. Look at all of the orbitals here on cesium, all 6, 1, 2, 3, 4, 5, 6. And notice this lone little electron all the way out here, far, far away from the positively charged nucleus. So it's going to have less of an affinity for that electron. It's going to more likely lose that electron. So its electronegativity is going to be lower. And so hydrogen's electronegativity is going to be higher because it has a greater tendency to hang on to that electron. And here's a picture of fluorine. You can see hydrogen just has 1 little proton, but fluorine has all of these 7 protons in the middle, which is going to hang on to those electrons, those valence electrons, more securely. And so that's electronegativity. When we are figuring electronegativity, there is a number. Let's move to this periodic table. There is a number right here. So neon's electronegativity is 3, and oxygen is 3.5, and notice fluorine has 4. Fluorine is the most electronegative element on the periodic table. So to find bonds, or the types of bonds, we're going to be using this electronegativity, and we'll do that in the next video.